So, today we're going to look at 7.3, which is on solving trig equations, very similar to what we did at the end of yesterday. So you find all the solutions using the intersect, and then put plus the period times n. The kind of problems we looked at yesterday were like this. You had a single trig function on one side, single number on the other. We'll review one of those. But then we're going to get into solving problems that have more than one trig function on one side. And we're still doing it graphically. So you're still going to put something in y1 and y2 and find an intersect. Or in this case, put everything in y1 and calculate a 0. But what makes it a little more complicated is what's the period? We have to find the period of this whole thing. And that's what I'm going to show you how to do. Right. Period of this, not as bad because there's only one trig term. But when you have more than one, that's what we have to talk about. So, how do you find solutions to trig, and a better word here would be equations? Well, the first step is the same as what we did yesterday. Find all the solutions within one period. If you set your window to be more than one period, you might have too many solutions. If you set it to less than one period, you might miss a solution. So you want to set it to exactly one period. Once you find all the solutions in one specific period, then you have to generalize it and tell me, okay, here's two solutions, but how do we represent all solutions? That's where you take into account the period. And you take the solution that you found using the intersect, or the 0, depends on how we do it, and you put plus the period times n. Okay, so that's how you find all solutions. So it's exactly what you did yesterday. There's nothing new here. Okay. So let's start with a simple one where we already know how to find the period and just review that, and then we'll get into a more complex problem. All right, so find all solutions. Does anybody remember what the formula was to find the period of a sine function? Yeah?
2 pi over b.
It was 2 pi over b. In this case, b is what? What's the number that's in front of x? Yep.
1.
1. Think of it as a 1. So the period here is 2 pi. Okay, so that number does a couple things for me. 1, it tells me how to set my window. 2, it tells me what to put on the end of each answer. In this spot, right there. So those are the two things it tells me. All right. So let's put sine of x. I already have that in y1. Let's put 0.8 in y2. Check my window. Remember that the width of the window has to be the length of one period. So you want the window to be 2 pi units wide. You could do 1 pi to 3 pi, you could do 5 pi to 7 pi. That's why I don't like to always read off the answers from this section, because the book doesn't use the same section that you might. I would use the section from 0 to 2 pi. That's what I would use here. And hit graph. All right, so how many answers do we get per cycle? Yeah, okay. 2. 2 answers per cycle. First step, find those specific answers, and then go from there. So let's call the answers x1 and x2. And since I put something in y1 and something in y2, I want to calculate where these two graphs, what? What's the calculate that I'm going to use? Yeah. Sarah? Where they intersect. So if you do second calc intersect and you just hit it randomly, you'll find one of them. 2.21. Now I got to be a little bit more careful with the next one. Second calc. There you go. Intersect and just move it a little closer. You get about 0.93. If you stop there, you haven't done that. You found two solutions, not all solutions. So what do I put on the end of each one of those to represent that answer repeating every cycle? Yeah.
Plus 2 pi n.
Plus 2 pi n. And remember what that means. N is an integer. So that means if you take and add 2 pi times 1 to the answer we got, you'll get the answer one cycle away. If you do 2 pi times 2 and add that to 0.93, you'll get the answer 2 cycles away. Okay, so n is basically how many cycles down you're moving to get the next answer. And if n was a negative number, it would bring you back cycles, okay, before the ones you started with, because this repeats forever in each direction. Okay, questions on that? All right. So, hold on one second. Yeah, we can write this. So if you put everything, if you do a y1 and a y2, you're calculating an intersect. But if you have an equation that's equal to 0, then what you want to do there is calculate the roots, or calculate the zeros. Does anyone remember from when we've calculated roots before? The roots are where the graph crosses what? Yeah?
X-axis?
The x-axis. So in a problem where it's already equal to 0, most of the time I would just leave it that way and calculate where it crosses the x-axis. Okay, so these mean the same thing. Setting an equation equal to 0 and solving it gives you the roots. It gives you the zeros. So, I mentioned that because we're going to do some equations that are equal to 0 in a little bit. So we're going to have, we can just use a y1 for this and see where this graph crosses the x-axis. We don't have to do an intersect on this one. So how do you find the period of a more complicated trig, let's say, equation again? What I would consider to be a complex trig equation would be something where you have multiple trig terms, like a cosine and a sine. And you're also raising it to a power. We've never done that. So what does raising it to a power do to the period? We'll see. So to find the period of a complex trig equation, start by finding the period of each term. And specifically, each periodic term. You don't have to worry about the period of something that's not a trig function, because it doesn't have a period. This is a term, plus 1, but we call that a constant term. Plus 1 has no period, so you don't have to worry about that one. Just the trig functions. Once you find the period of all the trig functions in your equation, then find the LCM of that. The least common multiple is the period of the entire problem. So let's say we're doing a problem and one of your terms had a period of 2 pi and the other one had a period of 3 pi. what would be the least common multiple between 2 pi and 3 pi? So this is a number they would both divide into without a remainder. They'd go into this number evenly. Okay? So the least common multiple, it would have to be greater than or equal to each of the individual numbers. So think if you were finding the least common multiple of 2 and 3. It's the same idea, except add pi onto your answer. That again? 6 pi. Yep, the LCM here is 6 pi. That's the smallest multiple of 2 pi and 3 pi. So if you have one term that repeats every 2 pi, and another term in your equation that repeats every 3 pi, then the entire thing will repeat every 6 pi units. That's the cycle of the whole equation. So before we do any problems, I'm going to give you kind of a little chart that explains how to find the period of any trig function we're going to do today. Doesn't matter what it is, doesn't matter what power it is. This chart will describe all of it. What are the two main formulas we use to find the period? T equals, what's one of them? Yep.
2 pi b.
2 pi over b is one of them. And the other one is?
Pi over b.
Pi over b. Then you use those same two formulas here. Except those two formulas apply to a lot more things than you know right now. They are very universal. So if you have any of these cases, sine, cosine, secant, or cosecant raised to an even power, any even power, or you have a tangent or cotangent, period. Tangent or cotangent to any power. The formula that you always use to calculate the period is pi over b. That's the formula. Pi divided by b. And again, b is number in front of x. Now, if you're wondering why I put absolute value, is because the period, or the t, that's the length of something. It wouldn't make sense for you to tell me the length of something was negative. So there's, I guess you could look at it this way, there's 12 different cases that you can have. This formula covers 8 of them. Sine, cosine, secant, cosecant to an even, tangent to an even or odd, and then cotangent to an even or odd. So that's 8 cases that are covered. What this one doesn't cover is sine, cosine, secant, and cosecant to an odd power. That's going to be 2 pi over b. So those other 4 cases are going to be 2 pi over b. Yeah. I spaced it out. I can't really get it on the screen all at the same time. Does everyone have the first part? Okay, so second part. That's the sine, the cosine, the secant, and the cosecant to an odd power. So I guess you could just put after that, if it's not one of these, then use 2 pi over b. But if it's not one of the ones above, it'll have to be one of these I have on the board right now. Okay, so any questions on that, those two tables? All right, so what we'll do now is we'll take a look at some examples and see if we can find all solutions and find the period of an entire trig equation that's a little bit more complex. Let's look at this. So in this problem, it's already with a 0, so you're going to be finding the zeros. You're going to look for where it crosses the x-axis. Cosine to an even power. Can someone remind me, what's the formula for the period when you have cosine to an even power? Is that Eli?
Pi over b.
Pi over b. And what's b in this case? Yeah. 1. It's the number in front of the variable of the argument. So b is 1. So pi over 1, the formula, or the period here is just pi. Now sine, this is technically sine to an odd power. It's sine to the first. It's the same one that you're used to using for sine all the time. What's the period of sine? Basic sine function. Yep.
2 pi over b.
Yep, in this case b is 1 again, so the period is just 2 pi. Now, what's the least common multiple of 1 pi and 2 pi? Tyler?
2 pi.
2 pi. So again, this number tells me two things. It tells me how to set my window, and it tells me what I need to put on the end of each answer. So let's set our window first. What would be a good x min and x max that's 2 pi units wide? Jake?
0 to 2 pi.
Yep, I do 0 to 2 pi, and I think I already have that in there. Now, let's type our problem in. 2, and what this means, this cosine squared, you can't type it in like that on the calculator. This means this. That's how you have to type it in on the calculator. But the way that you do it on the left, that's just how people always write it on paper. So we have 2 cosine x. Very important I close the parenthesis. Otherwise, you're going to be doing the cosine of x squared. That's not what you want. You want the cosine of x and then square the whole thing. All right, so we get that. Plus sine x plus 1. Okay, so that is how you would type it in. Okay, hit graph, and it should always end where it started, because this graph is one cycle. So in order to connect to itself, this point and this point should be at the same height. So if you copy and pasted it, it would line up perfect. Okay, so here's our graph. And how many answers does it look like we get per cycle? Yeah.
1.
1. You could zoom in here and check and see, does it actually go below and come back? But it doesn't. So let's do second calc. And remember, you're calculating where it equals 0. So which option do I want to pick? Chris?
2.
2. So pick a point that you know is a little bit to the left, to the right. Do your guess. And it tells me x is 4.71. Another reason I don't like to read the answer here is because a lot of times the calculator will write that as a fraction with pi, and it's fine if you do it as a decimal. Okay, so 4.71. But all you've done right there is find one answer. What do I put on the end of that to indicate all answers? Yeah, Eli?
2 pi n.
Yeah, you're going to put the period, which is 2 pi. That's the LCM. And you can add any multiple of that and get another answer. And that's the answer. Okay, any question on that? All right. We could do this one two different ways. You could do a y1 and a y2 and then find an intersect. Or let's set it up so we can do it like the last one. So how would I get this equation equal to 0? Yeah?
Subtract tangent x.
Yep, you could subtract tan x. Again, this is purely if you just want to do it the way we did the last problem. All right, the period of cosine. It's just cosine to the first power. What's the period? Yep.
2 pi.
2 pi. What's the period of tangent? Just regular tangent. Tyler? Pi. So it's actually the same LCM we had last time. That LCM does come up a lot. So the LCM of 2 pi and pi is 2 pi. And now let's type it in. So we've got 3 cosine x minus tan x. Now, I know cosine has a range of -1 to 1. What's the range on tangent? How high and low does that go? Ashley? Yeah, that goes negative infinity to infinity. So as far as your y min and max, I mean, it's not super critical here, but I would probably go like -8 to 8, -10 to 10, that'd be fine. And now, let's hit graph. Okay, so that is what our graph looks like. And if you were to graph one more cycle, let's see if that stayed together. Yep. The next cycle would look like that, roughly. That's the next, and then you copy and paste that over and over to see your graph. All right, so how many answers do we get per cycle in this one? 0? 2, yep. I think it's pretty clear this time. There's nothing tricky or that you have to zoom in and look at. So 2 answers. Both of the answers are going to have a plus what on the end? Chris?
2 pi n.
2 pi n. So let's just take care of that. And now find those 2 answers. Second calc 0. So that one. So one of our answers is 2.13. And the other answer is, ooh, I think I got it barely enough room on that. Yeah, 1.01. Now I wrote it that way because the directions specifically said, oh, if the directions just said find all answers between like 0 and 2 pi. Let's say those were the directions. That means you set your window to 0 to 2 pi, and you write down the answers that you see, and that's it. You don't put plus anything on the end. So if this is what the direction said, that would be the answer. Because they specifically want the numbers between 0 and 6.28. They don't want anything else. If they want something else, they'll write all. And then you write it this way. Most of the ones we do today, I think all of them, we do the plus period end. Questions on that one? All right, let's try this one. All right, you tell me, what's the first thing I have to do here? Yeah, Eli?
Put the cube around the 2x also.
So when we type it in, yeah, we'll have to put the 3 over after the argument. But even before I get ready to use the calculator, what do I have to figure out first here, Matt?
Periods?
Yeah, I need periods. That's what I need first. What's the formula to find the period of sine cubed? Sarah? 2 pi over b. And what's b in this case? 2. So the period of sine cubed, it's going to cycle every pi units. How about cosine? What's the period of cosine? Jake?
Pi over b.
Yep, and b in this case is how much? 1. So that one cycles every 2 pi. That's every 1 pi. LCM, same thing as what we did before. Don't assume it's always 2 pi. It's just that does come up a lot. Okay, so now we've got that. Window. I think our window's fine. It's already 0 to 2 pi. Now when we type that in, you want to be careful that you don't cube the 3. You don't want the 3 to turn into a 27. That's not what they want. So to type it in, we're going to type 3, and then we're going to put in parentheses what we're going to cube. Sine of 2x. Close the parenthesis because I'm done my argument. And then I'll put cubed. I might have an extra set of parentheses there that I might not need. But doing it that way, it guarantees I won't cube the 3 because it's separated from the exponent. All right, and then put in minus 2 cosine x. And hit graph. Okay. So, how many solutions does it look like we get in this one? Chris?
6.
Yeah, there are 6. 1, 2, 3, 4, 5, 6. Probably more than you'd have on a test, but I already have all 6 of them done out, so we don't have to do second calc 0 6 times. Okay, so the 6 answers that you get are 0.5, 1.25, 1.57, 1.89, 2.65, 4.71. And all of them, I'm just going to write it probably not the most mathematical way, but they all have a plus 2 pi n. Or you can write it separately on each one. Okay. Any question on that? So this one's not really that much harder. The thing that's just a little annoying is you got to calculate 6 roots. And you wouldn't have that many on a test. But I'm showing you, you can end up with quite a few. All right, so let's see. Yeah, last thing we're going to look at. We did solving trig equations. Now we're going to look at solving a trig inequality. Let's go back to one of the first ones we did. That's a good one. And let's say I wanted to know where that graph was below the x-axis. Well, from 0 to 2 pi, that would be from here to here. So there is an interval that starts here and stops here that's below the x-axis. How often is this section that's below the x-axis going to repeat itself? In general, it's that section that's below the x-axis, you're going to find that section in every, what? Yep.
Every interval? Or
Every, yeah, period. You're going to find that in every period. So once you find where it's below the x-axis here, you can do exactly the same thing that we've done all along. Find the interval for this window, and then put a plus 2 pi n on the entire interval. And that shows that that interval would repeat later on. So it's basically the same thing. You have to still find these 2 points. But then instead of writing equals, you build an interval from it. And it's usually where you're either below 0 or above 0 or above or below something. Okay? That's what you have to look for. Right, so the first thing you do is you treat it just like it was an equation. You graph it, and you find all the roots or all the intersection points in one cycle. Once you do that, then you take into account the inequality. Do you want to know where you're above a certain region or below a certain region? Is it equal to, in which case you could use a bracket, or is it strictly a greater than or less than? And then you'd have to use a parenthesis. So the answers here, in fact, when we're solving an inequality, I can pretty much say the answers are always going to be intervals. They're not often, but I think, yeah, they're always going to be an interval. And keep in mind vertical asymptotes, because a vertical asymptote breaks your interval. Okay? It breaks it in half. So let me go back to one of our problems we had that had an asymptote in it. This one doesn't, but this one did. So let's say you wanted to know where this graph is below 0. Well, below would mean not including, and you'd have that section. But then where this section ends is right there. That section starts at this point, which I could find on the calculator. In fact, I did. It's 1.01. And it ends at the asymptote. That asymptote breaks that interval. And then it starts again, and it's below the x-axis again from 2.13 up to that asymptote, and then the asymptote breaks it again. Okay, so the asymptote stops your interval. Okay. Right, so let's look at an example. And let's set this up just like we've been doing. Let's get 0 on one side by moving sign over. So I just, well, I could do it that way, but let me do it this way. So we have cotangent x minus sine. All right, so we moved sine to the other side. Now let's find our periods. What's the period of cotangent? Yeah.
B.
Yep, and in this case b is 1, so just pi. And what's the period of sine? Okay. 2 pi over b. In this case, b again is just 1. We did do an example where b wasn't 1. A lot of times it is 1. Least common multiple, 2 pi and pi is 2 pi. Okay, so that tells me how to set my window. So let's check that. Window looks good. How do we type cotangent in? Because we don't have a button for cotangent. Ashley?
1 over tangent.
Yep, we're going to do 1 over tangent. That's a reciprocal identity, and that's more what we're going to talk about tomorrow. We're going to talk about identities. So 1 over tangent means cotangent minus sine. And we're looking for where this is greater than 0. Where is my trig graph above 0? Okay. Let's pull that down over here. Like that. All right. How many intervals on this graph, on this window, is my trig graph above 0? How many sections are above 0? Yep, Jake? 2. Here's 1. Open circle there because it ends, but it does not mean it can equal 0. It has to be greater than 0. And then again, from here over to here. All right, so this is interval 1, this is interval 2. We have to describe each of those intervals, where they start, where they stop. Let's see what we can write out. Well, we know there's going to be a union between the two of them, because whenever you write 2 intervals, it's either this one or this one, because there's 2 answers. Where does interval 1 start? You're looking for the x value, where it would start. Well, how about where does it stop? Where does interval 1 stop? What would we have to do to figure that out? Yeah. Okay.
Find 0.
Yeah, we'd have to find the 0. Okay, so we can find the 0. Second calc. Zero. And then get your 0. All right, so interval 1 stops at 0.90. Including or not including the 0.90? Yeah.
Not including.
Not including. It can't equal 0. It has to be greater than 0. So not including. And now we still have to figure out where does interval 1 start. So it stops at 0.9. But where would the start of it be? Yep.
Infinity?
Infinity would mean that's like, it would mean it goes on forever. That our interval, well, that would mean our interval has no end to it. Or usually infinity is on the right side of an interval, negative infinity is on the left. But our interval definitely has a start and a stop to it. It's only, our interval is only in this section right here. It has a definite beginning and end. Anyone see where the beginning is? Yep.
0.
When x is 0, including or not including?
Not including.
Right. It's going to be a parenthesis not because of this symbol. It's going to be a parenthesis because it's an asymptote, and you can never include a value that's an asymptote. So remember, when you're describing an interval, you're looking for an x value. That means where is the left edge and where is the right edge. Not the top and the bottom. That's range. Interval is about domain, left and right. So starts at 0, ends at 0.9, at 0.9. All right, let's look at interval 2. Now, there's another asymptote right here. Where is that asymptote? It has to be pretty easy to figure out. If you know the width of the window, and you've got that asymptote, it's right in the middle. Where does that mean the asymptote would be? Yep.
2.
Well, this is 0, right? What's the right edge of my window? I didn't put in 5 as my x max.
2 pi.
2 pi.
Oh, it's a pi.
So that asymptote is right at pi. So this interval starts at pi. And how would I figure out where interval 2 stops? Yeah, here. Find the 0. So let's do second calc 0. And make sure you're just a little bit to the left, to the right, and do a guess. Okay, so 5.38. Questions on that one? Now, let's go back up and see, did it say to find all? Or did it just say to find the answers on one cycle? All. So that means this entire interval, okay, if you want to write it properly, this is how it would look. 0 plus 2 pi n and 0.9 plus 2 pi n. You can add 2 pi n to everything. The way I normally write it, instead of writing it out like that, is I just put this. This just means add plus 2 pi n to the whole interval. Same thing here. Add 2 pi n to the whole interval. And if you added 2 pi n one time, that would give you the next set of answers in the cycle to the right. If you added 2 pi n 2 times to all these numbers, you'd get the next set of answers 2 cycles to the right. Questions on that? Okay, so more formal, a little bit less formal, but that's okay. Let's look at this one, so the last one. So a double inequality isn't really that much harder if you're using a calculator. It's basically where you put something in y1, something in y2, and something in y3. And you're looking for where a graph is not only above something, but also below something else. Basically where it's sandwiched. between two things. So double inequality is where you're looking for where a graph is sandwiched between two other graphs. You don't have to have a color graphing calculator for this, but it really helps if you do because you have so many graphs on the screen. It's easy if you can identify it by color, like, okay, here's the red one, here's the blue one. I'm looking for where the green one is between the red and the blue one. But again, you don't need color to do this. All right, so we have negative x, we have x sine x in the middle, negative x on the left, positive x on the right. That's a line that goes through the origin. Think of y equals mx plus b, and a slope of -1. This is a line that goes through the origin, has an intercept of 0, and a slope of +1. So we're going to have an x shape between these two lines. And we're going to look for where this is sandwiched between the x shape. And I'm going to color code it once I figure out what colors I'm using. So let's put negative x in y1, x sine x in y2, and positive x in y3. So this one was the blue. This one is the red. And this one is the black. So color-wise, what we're looking for, where is the red graph above the blue, but below the black? That's what we're looking for. Above blue, below black. All right. I'm going to do zoom 7 on this one. That's a trig zoom. There's my start of my X shape. Let me zoom out more. So notice that graph in the middle, that x sine x, that's what we call a variable vertical stretch. So if you look at this middle one, this right here is where we normally put a number that represents a vertical stretch. Well, it's a variable. So it's a variable vertical stretch, meaning the further away you get from the origin, the taller and taller and taller it gets. The closer you get towards the origin, the more it shrinks. So now let's see if we can look at that and get our answer. We're looking for where the red graph is above or equal to the blue, but under the black. Did anybody see the x values where that happens? Above the blue, but below the black. Chris?
From 0 to infinity?
Yeah, anywhere from 0 to the right, you will be above the blue, but you're also under the black. If you go less than 0, that's reversed. Less than 0, you're under the blue. No, we want to be above the blue, not under the blue. Okay, so above the blue, below the black. So anywhere from 0 to infinity. So you really don't have to say stop at infinity. You could just say greater than or equal to 0. Okay, any questions on that one? So that's a double inequality. All right, so that's the homework for tonight. Tomorrow, just a normal day, but I think the plan for homework tomorrow night most likely will be a take-home test on this section. I think that's the